Hello, good evening everyone. This is Shivani Birada from Student Coding. Welcome you all on the new Friday of our webinar series. Today we have our guest is Srushith R. He is the head of engineering in a Hub. So what is a Hub? Hub is like a building community, the one-step platform for technical conferences on the AWS Star, the primary using a serverless and other associated services. So he got the first taste of a serverless by participating in the AWS chatbot challenges and felt he interested love with the technology and the unparalleled passion for the lambdas henceforth begin. He is a regular speaker at the conferences and the meeting in the serverless communities and the sharing of knowledge, production experience and the real life challenges with the students. So today he is with us and he will share her experience and he will also told us the kickstart our your cloud experience with the AWS and the serverless. Hello Shrishit, are you there?
Hi, Shivani.
Yeah, so welcome you again and so you may proceed with your session.
Thank you, Shivani. Hello, everyone. Very warm welcome to the session today. And today's topic is about kickstarting your cloud journey with AWS and Serverless. I don't know how many of you have built something or explored on the cloud technologies or on AWS for that matter. And I don't know how many of you have worked on this crazy, beautiful, interesting technology called as serverless. You probably can comment as in the comment section to let us know how many of you have used it. So today's topic is about, I'm going to introduce you guys to AWS and predominantly the various AWS services that is towards the serverless paradigm and help you get started with it so that you can build some really interesting, cool applications. A little bit about myself. I'm Srushith R. I'm the head of engineering at Confab. Confab is a ticketing platform where we help people organize events and technical conferences. I'm also a serverless consultant, co-organizer of one of the largest serverless meetup groups, that is the Serverless Architecture Meetup Group in Bangalore, and I'm also a mentor at Girls Grid Bangalore. So if you guys want to understand or talk about anything AWS or serverless for that matter, you can always reach out to me on LinkedIn, Twitter, and I'm pretty much active everywhere. And we can have a chat and discuss about serverless. So at the rate Srushith R is my Twitter handle. You can always reach out to me there. Follow me for really interesting uh, serverless and AWS content. Now, before I start, because this is an introductory session about AWS, I just wanted to give you guys a brief understanding of what AWS is. These are basically a few of the AWS services, the icons of the services that is offered by AWS. A few of them, and as you can see, AWS is nothing less than an ocean where you have so many services for us to play around, build our applications, and deliver business value to our customers. Uh, the number of services is numerous, and the amount of value it adds to your application in terms of performance, scale, costing, security, and various other things is invaluable. And we will be talking about a few of those things in our session today. So just to give you guys an understanding of how big or how powerful AWS is, this one diagram should answer that. And with the latest survey or report from Gartner, it is understood that AWS has been the leader in the cloud for 10th consecutive year, this year as well, including. Now, this session is predominantly towards serverless and what are the advantages, and especially as students who are probably building some POCs, some sample applications, building your own websites with a portfolio and various other things. Why serverless is going to be really helpful and why it is very easy for especially students and people who are getting started with the cloud to get started and probably build a simple application out there just like that without a lot of effort or without a lot of things to consider for that matter. And I'm assuming a lot of you would know what is a server, so obviously I'm not going to talk about that. But what I will be stressing upon today is the various problems and the various things that we would consider when we have a server in place. So these are the few problems when it comes to servers, right? So you have a server size. So whenever you build a virtual machine, like for example in the AWS cloud, you have an EC2 instance or any virtual machine in the cloud. So you will have to have a few configurational details, like what is the kind of machine that I want to provision, what is the RAM of that machine, how many servers I want to provision, and when there is a lot of scale or a lot of requests coming to my, let's take a simple example. You have a portfolio website, right? Or where you have put down all the details about yourself, the list of skills you have, and the list of projects that you have completed. Now, what you would do, you would have a web server, and your application would be running in it. Your website would be running in it. So, because for students and for simple websites, it's not a problem. But in case of a real world application where you have real consumers and customers that are accessing your website or your product, what happens is it becomes really important to consider a few factors. A few of them are listed here. The first one I would like to talk about is the server size. So you provision, let's say, for example, a virtual machine, which is of 2 GB RAM. Then there is a physical limitation as to the number of requests that particular server can serve, right? Because obviously it is a 2 GB RAM. You don't want to run so many things, or you cannot serve millions of requests from one particular machine, which is 2 GB of RAM, right? So what you essentially would do, you will scale it. That means you will add more virtual machines, more EC2 machines into your application, into your fleet of servers, and what will happen? The load is distributed across various servers, and therefore your application is served for more and more people. Now, what happens is, as and when there are so many people coming into coming to your product or your application, what will happen? You keep on adding more servers into your application so that you have more muscle power from an application perspective to serve requests to the users who are visiting your website or your application, right? So server size or server provisioning is one of the basic things or basic things that anybody would do when there is some request that is coming in for your application, right? Server size. Now, what is the problem with the server size? The problem is, how would you know how many more machines do I have? Do I need to add, right? So you set up a 2 GB machine at the very beginning. That's fine. It is serving, let's say, for example, 1,000 requests that is coming in. Now, you have done a really beautiful website, a beautiful, brilliant product. There is traction for your product. So more and more people want to consume it, right? So what will happen? There will be more and more requests that is hitting your website, and your website should still serve. So what you would do, as I already mentioned, you will add more servers. Now, how would you define what is my second server that I'm attaching, right? What is the RAM configuration going to be? What is the power that I have to add to my application? And how many extra servers do I need to add? Is it one? Is it two? Is it three? All sorts of questions come into picture, right? So that is what is called as capex planning, capacity planning, or capacity management. Essentially, what happens is you're trying to analyze the traffic that is coming to your website and try to provide equivalent infrastructure behind the scenes so that you can serve those requests, right? To give you a simple example of how provisioning and stuff like that works, a few years back, what would happen if there's a cricket match, and let's say, for example, there's this particular scenario which happened was we used to watch cricket score in Crickbus, right, where you get the list, where you get match score, commentary, and stuff like that. There was a particular scenario when Sachin Tendulkar was nearing his 100th century, right? And what happened is the servers crashed because there were so many requests that is coming in, and they were not able to serve. The similar case with I don't know how many of you guys remember the first Flipkart Big Billion Day. I don't know how many of you were fortunate enough to buy products at such a low price, but then the first billion day had so many issues because they did not anticipate so much of traffic coming to Flipkart, and they eventually conked saying that, okay, there are too many requests that is being served right now. We cannot serve your request, so please come back later. right? Again, that was the very beginning of so many years back, right? So what happened is you don't know how much traffic is going to come to your website, and capacity planning can only be done to some extent, right? You can only anticipate the number of requests to some level. You cannot really say that, okay, I'm going to expect 1,000 more viewers, and you get 10,000 more viewers. You never know, right? It's not in your hands. So therefore, capacity planning is something that is very not so easy from building applications. There are so many other ways where we have something called as auto scaling and stuff like that, where what happens is you write a set of rules in your application that says, if at all my first machine's CPU is consuming more than 80%, then automatically add another machine to my fleet of servers, right? Or let's say, for example, that the number of requests that is coming in is greater than 1,000, then add another couple of servers. So you can define a set of rules in your automatic scaling where you can automatically add more machines to your application. But then again, you have to do some sort of a planning, right? So that's something that is a little bit difficult about servers. And then effective server utilization. I gave you an example where you did not expect so many people who are coming in, right? Let me take you through a different example. Now, let's say, for example, you built an amazing product. Yeah. Let me give you an example where you have built a website that uploads where you intake, let's say JPG images, and you return, let's say PNG images. So essentially, you have built a small product where it converts JPG images to PNG images, right? Now, what happens? It is beautiful, it is working wonderful, and you have tested it out with different kinds of images, different sizes of images, and everything is working fine. Now you deploy your product, your application, and then now you are waiting for people to consume it, right? So what would happen is you have provisioned a server, which is again of 2 GB RAM, but then your application is a new application. Nobody knows about it. That's number one point. And the other thing is, there are not many people who knows about it, right? So there will not be so many people who are coming to your website, which although does a brilliant job, but then there are no consumers. Although you provided 2 GB of machine, which can serve like thousands of requests, you're hardly getting tens of requests, 15, 20, and stuff like that, right? So what is happening is here you have a larger power in your hand where your application is capable of serving more and more requests, but you're not getting requests, so many requests. So it's the flip side, right? Where you first case where you have power, but there are so many requests coming in that you're not able to serve them. The other scenario that we discussed is basically when you have enough power, but then you don't have a request that is coming in, right? So both of them are plausible scenarios. So that is what is effective server utilization. You don't know you have provisioned a server, but but it's underutilized. And then you have budget decision as to, okay, I said I'm provisioning 2 GB RAM of a machine, right? Now should I provision 1 GB or should I provision 3 GB? All sorts of decisions, right? And all of this is obviously combined with cost, because when you are creating a virtual machine on the cloud, you are going to pay for every hour that particular machine is running for you. In AWS Cloud, we have something called as EC2 instances, which is nothing but a laptop in the cloud for people who are pretty new to the cloud, right? So it's like you have a laptop for yourself, but it is just that it is in the cloud. You connect to it via internet, and you have a client with which you can connect, and you can have a virtual machine for you that is in the cloud, right? So what size of the machine that I have to configure? I mean, I have to provision, right? So budget decisions, obviously cost comes into picture, right? In the second scenario where we talked about, as you provisioned a 2 GB RAM, but nobody's coming. So essentially, you have power, but you're not serving anybody. So it's as good as you are running in losses, right? And then scaling, as we discussed in the first scenario, where there are so many requests coming in, I don't know what to do. I'm adding more and more servers. I am doing a lot of manual work, or even if you do a little bit of automation, you have to do a lot of planning. And there's something called as load balancing and patching, security updates, and the list goes on. With the world of servers, Obviously, it's a brilliant thing where you have a server in the cloud that you are not maintaining, or you are not wiring that server, or you are not taking care of what happens if there's a power cut of sorts. Although all those things are taken away from you, but still, there's a lot in your hand apart from writing your application logic. That means apart from building your application, you have to do all these things. What happens if there are more requests? What happens when there are less requests? How do I provision? How do I plan? How do I budget? All sorts of things, right? And then obviously security patches and all those things are a different level altogether, wherein you have a server, right? It's like you have to install antivirus. Again, in layman terms, for people who don't know what is a virtual machine and who have not worked in the cloud, uh, let's say you have a Windows machine, and Microsoft has released a security patch for a vulnerability bug in the OS. Right. So what happens is, if it's your machine, you will have to download that. You will get updates, right? You will say Windows updates is available, security patch update, and stuff like that, where you manually download that update, and restart your machine for that update to apply, right? The same thing happens with the server also. It's just that it's not your own computer which you own. It is a rented computer that is not in your hand, but then it is available for you, right? So what happens is as simple as that. So whenever there's a security patch that is coming in for a Windows machine that Microsoft has launched, you will have to manually install those patches, because that's a security vulnerability bug that Microsoft has found and also fixed. But then you'll have to install that update onto your machine, right? So you'll have to do that. So things like this, there are a lot more things, and it is really painful sometimes, right? Now, what happened next? So what happened is, this is how the computing evolution has happened, right? On the y-axis, we have the level of abstraction, and on the x-axis, we have the focus on business logic. Now, what exactly is the difference between the x-axis focus on business logic? Which means that apart from my application that I'm building, what else should I be concerned about? What else should I take care of? That is the x-axis. And the y-axis is the level of abstraction. Again, what all things are taken away from my hand, or the degree or level of things that are taken away from my hand versus how much I have to handle myself. Now, the first part of our evolution has been the physical machines, where requires guessing, planning. I told you, right? You have to guess the number of requests that is coming in, and then lives for years on premises. On premise, okay, I don't know how many of you know what is on premise. On premise is basically you have a big rack of server where your software is running. That means it is in your location, in your office, in your home, in your startup, wherever it is there, and you are maintaining it. That means you have to provide electricity. What happens if there's a power cut? All sorts of things. That is on-prem. That means you are maintaining. It's all yours. It's like a bigger laptop that you own. In simple terms, right? It lives for years on premise. Heavy investment, as I told you, capex, right? Capacity expenditure. Now, why it is heavy investment? See, you have to buy a laptop, right? When you buy a laptop, it costs you so many thousands. Imagine buying a server, right? You will have to pay a lot more money. And then again, along with that, there's a lot of maintenance that comes into picture, right? Power backups, generator costs. And then again, you can't have a server just like that, right? If it's a big server, then you need some cooling mechanisms and stuff like that. And obviously low innovation factor, because that server is just yours. And then the various crazy services that is available on the cloud will not be available for you, because it is your own maintained thing. And then you deploy it in months. That means what has happened is, you built an application that is getting deployed to production very rare, in months sometimes, right? So these are the various issues with having physical machines. Now, what did we have next? Next came in the virtual machines, right? So what happened is, here we had hardware independence. That means instead of having that server in my house, in my office, I said that, okay, I'm going to rent it from somewhere that is in the cloud. Again, for people, to give you guys some analogy about easy understanding of what is the difference between cloud versus on-prem or having it yourself, just take this simple example. You buy your own car, okay? So how much investment goes into buying a car, right? You have to buy the car first of all, and then you will have to take insurance. You will have to learn how to drive, right? Obviously, you have to maintain that car. So if at all there's a tire burst, right, you will have to know how to change a tire, right? And then change of engine oil and all sorts of things, right? So you'll have to understand all those things, and then you can start driving your car, right? Obviously, it is your own, but the amount and effort of things that gets into buying your own car and driving your own car is a lot. Now, that is what is on-premise, or in simple terms, if you own your own server. Now, coming to the cloud, what exactly is the difference? The difference is essentially you have an Ola or a Uber. See, end of the day, why do you want a car? You want a car to go from one place to another, right? So that is the purpose of having a car, right? You want to go from one place to another. Now, there are various ways of how you can do that. One is obviously you can walk to your destination. The second one is obviously if you have your own car or your vehicle, you can take that and go to the destination. The other one is you can use an Ola or an Uber, right? Where you are leveraging someone else's car. That car is not yours, and you're not maintaining that. You're not driving that. It is just that you are consuming. Okay. So virtual machines is not exactly that. Virtual machines is more like you renting a car, not Ola, Uber. I'm sorry, renting a car, like in a Zoom car, right? Where you don't have it for yourself, but then when you want to go somewhere, you will say, okay, give me that car. I will keep it with me for 1 or 2 days. I want to roam around my place. I have some work, so I'll keep that car with me, and I will pay you for that, right? So that is what is Zoom car, where you rent a car for yourself. Again, what are the advantages versus having your own car versus renting? The thing is, first of all, you don't have to buy the car yourself, which is a heavy investment, right? A few lakhs. Now, in renting, it boils down to a few thousands if you have it for a few days, right? But still, the maintenance and all those things are still in your hand. Let's say while you took a Zoom car, you're going somewhere, the tire burst. You still have to change the tire, right? You still have to manage it. So that is about operational expense. That means while I'm operating it, what is the various expenditure that I'm putting? Now, again, with virtual machines, as I said, hardware independence. That means that you don't have to buy that hardware anymore. It is just that you're renting from somewhere. Trade between capex for apex or opex, which is operational expenses. You're not caring about capacity expense. That is, you're not caring about capacity planning in terms of how much of a big of a server I have to buy. Versus here, it's more about a maintenance, right? I can rent a server however big I want because it's just available in the cloud. It's more about how much I'm spending to operate that particular server. And then here there is more scale because obviously if you have your own server, there are so many requests that is coming in. It is not like a chocolate, right, where I can go to the general store and I can buy a new chocolate. It's not like I can go somewhere and buy a server immediately and attach it to my fleet of servers, right? That's the difference between having an on-prem versus in the cloud. If you want more power for your application, you can instantly, at the click of a button, you can have another server that is deployed for you in a few minutes, right? Elastic resources, that means, as I said, it can scale automatically, not automatically. I mean, you have to obviously define a few things, and then faster speed and agility, obviously, because you can do whatever you want in the cloud, and there's a lot of flexibility as to what you want to do. And if you want to add a new server, it is a matter of few minutes, whereas if it is on-prem, you have to order that server, all sorts of other headaches, right? And then reduced maintenance, as I said, having your own car versus renting a Zoom car. Next. Next came in the power of containers. Again, I don't know how many of you guys have used containers, wherein what happens is, instead of having your entire application that you define, you are more confined to a smaller environment now. that is called as a container, where it's platform independent. That means you build an application and that application can run anywhere. Okay, so a container is a virtualized environment. Again, I don't want to get into the details of it because I don't know. I was told this is just for the students, so I'm not going to get into the details of how containerized applications are and what they do. In simple terms, container is like a small piece of your big machine. Okay, it has its own isolated environment for itself, and it has its own RAM, it has its own memory, it has its own sort of infrastructure for your application to run. It's like a small piece of your big laptop. Okay, and then consistent runtime environment, higher resource utilization, because what is happening is it's like you're breaking down your big machine into small chunks so that these smaller chunks can be utilized by multiple applications. Okay, and easier and faster deployments, because now your area of focus is very small, and you are only concerned about that containerized environment. Again, isolation and sandboxing is easy, as well as starts to deploy it in seconds. As I told you, in virtual machines, it's going to take you a few minutes to deploy, whereas here it's going to take a few seconds to deploy your container. Again, not getting into the details because it is a little out of scope for the target audience today. The next, that is in the last of the computing evolution as of now, is the serverless. We have two services from AWS, that is AWS Lambda and AWS Fargate. In today's session, we will be most likely concentrating on excuse me, on serverless. Now, what is serverless? Serverless is what are the advantages? I'll come to what is serverless in just a bit. Okay, to further, we talked about the analogy between your own car versus Zoom car, right? Now, this is where exactly Uber and Ola comes into picture in the analogy that we are doing, where serverless is more like you claim that service or you use that service only when you want it. Now, even with Zoom car, imagine you want to go from let's say Bangalore to Chennai. Okay, and you have some work in Chennai, so you live in Bangalore, so you are consuming that car only during the travel from Bangalore to Chennai. You have an office in Chennai. Okay, you go there because you have some meetings or some work there. So while you are in your meeting, obviously you are not consuming Zoom car. It's just lying in the park, in the parking, right? Now, what will happen is, although you're not using it, you are paying for Zoom car because obviously you have rented that car for yourself, right? Now, with Ola and Uber, what happens is, I exactly tell that, okay, I want to go from here to here, and only at that point in time, when you actually want to go from one place to another, the service, Ola or Uber, is coming into picture. They serve your request of traveling from one place to another, and they charge you only for your travel, right? They're not charging you for the maintenance that the car is having. They're not charging you for the amount, the EMI that the driver is paying for the car, all sorts of things. Correct? Ola Uber is exactly a perfect analogy for what you want to understand serverless. Serverless is basically, you have infrastructure that you are not maintaining. It's a car, but I'm not maintaining. I'm not driving. I don't know how, I don't need to understand how to drive a car. I don't need to understand various mechanisms of how a car works, and all sorts of things is taken away from your hands. All you do is you book a car, you sit in it, relax, and you reach your destination. As simple as that, right? So that is what exactly serverless is, where you have again, the advantage is there's continuous scaling, because what happens is, behind the scenes, there are, as and when requests are coming in, there is infrastructure or machines that is provided for you by the cloud provider. In this case, AWS takes care of providing those various infrastructure for you to serve requests for your application. Again, it is called serverless just because it doesn't mean that there are no servers. Okay, it is serverless because you don't have to maintain or manage the servers yourselves. Okay, you don't have to do that. Serverless is basically the cloud provider, AWS, Amazon, Azure, Google, GCP, all those guys are going to take care of it for you, and then what is that? You will not be able. You don't have to worry about all those things, right? Pay for value, as I said, in an Ola or an Uber, where you pay only for how much you consume, right? And zero maintenance, because obviously you're not maintaining the car anymore. Therefore, you don't have to pay for it. Similarly, here, you don't have to maintain the server yourself. You just have to just use it as and when it is available. Okay, I'm assuming it is clear until now. AWS Fargate is the serverless offering of of uh, um, of containers. So we will not be touching upon Fargate as of today. We'll be predominantly talking about a Lambda function for the rest of the time, right? Okay. So next. So this is how generally a traditional three-tier applications would look like, right? So you have a database list, you have database servers, which is nothing but the data layer. Then you have application servers, that is the business logic, that is all the code that you write is running on these servers. And then you have web servers, that is the presentation layer, which is essentially the websites that you're serving, right? Your application or your product is having. So this is how a traditional three-tier application would look like, where you have a fleet of web servers, fleet of application servers, and database servers, where all your databases are running MySQL, whatnot, right? So this is how a traditional three-tier application would look like. But then, coming to the modern three-tier application, or how it would be in the serverless world, right? This is how it would look like. So you still have the three layers, that is the data layer, business logic, and the presentation layer. Now what happens is, okay, I think this image is not loaded. Okay, my bad. So on again, this is all very specific to AWS cloud, but there are similar services on other clouds as well, GCP, Azure, and stuff like that. So what you have is the presentation layer. Here you will have AWS Amplify, which is a framework that is helping you build front-end applications or mobile applications. And then, of course, here is what is called as an S3 bucket. So S3 bucket is essentially used to store your front-end assets like your HTML, CSS, JS files that is going to serve the end users or consumers. And then this is what you have, a Lambda function. A Lambda function is a Lambda, AWS Lambda is a service, a serverless service where your business logic or application code lies, and this will take care of running all of your business logic. And then with serverless, everything is event driven. Okay, so I'll come to it in just a bit. What is exactly event driven? So we have Lambda functions, and then in this Lambda function is where you have your business logic, and then you have a set of events. So this Lambda function can connect to a database, just like your any application, right? You get a request, you do some transformation or some kind of a business logic on top of it, and then you connect to a database, get some data, query some data, or write some data into it, and then get the data back and serve that back to the user, right? Now we have a set of events. So what happens is in the Lambda function, you can have a lot of events that you can trigger. Let's say various services. Let's say we talked about the simple application where we are doing a JPG to PNG conversion, right? So all the converted images you have to store somewhere. So that's an event. So you want to store that in a S3 bucket, which is an AWS serverless storage offering, and which will store all the static content or files or images and all sorts of things, right? And then what we have here is something called as event bridge. Event bridge is nothing but like an event bus, which I'm assuming a lot of people would know what an event bus is, right? So you have a lot of events. It's like a queuing mechanism, right? It's like a queue. You have so many events that is coming in to your application or in your application, and you push all those messages into this queue or tasks into this queue, and then this queue takes care of delivering those messages to dedicated destinations. So that is what is Event Bridge. Event Bridge is again another AWS offering which helps you connect various other services into your application. To give you a simple example, we took that application where we have a JPG to PNG conversion application, right? So someone comes to our website, it is served from this layer. The content is in S3 and that is served. Now, the moment someone clicks on upload, an image is uploaded to your S3 bucket via a Lambda function, where the Lambda intakes the file, uploads it, and probably does a little more of processing, things like that. Okay. So what happens is when someone clicks on upload an image, we directly upload that image to S3, and from S3 we can trigger a Lambda function saying, okay, I got an image request. Now you have some algorithm to convert JPG to PNG images. So that algorithm is sitting inside Lambda function. Okay, now the image is uploaded in JPG. It triggers this Lambda function. That means it invokes this Lambda function. The Lambda function goes to that S3 bucket, reads that file, that JPG file from S3, does that algorithm or does whatever is your logic, converts it into PNG, and writes it back into and uploads it back to S3. Okay, now you have uploaded it back to S3. Now what we have to do, you probably want to send an email to the uploader saying that your conversion is completed. Here is a file that you wanted. Here's a PNG file. Now that is what we can use Event Bridge for. You completed the logic. Now you want to connect it to an emailing service. That is SES, again another AWS service which takes care of sending emails. Okay, where you push a message into the queue, into this event bridge, and the destination is going to be an SES, where it picks up that request and sends an email to the particular uploader, whoever is uploading. Now, this is another, as I said, this is the Fargate, where this is one container. So where AWS Fargate is a serverless containering offering, where it can scale automatically without you configuring for anything from a containers perspective. Now you have various queues and messages that you can have in your application that is responsible for talking to your databases. Again, in the serverless world, there are a lot of database options that is available. From an AWS perspective, you have something called as DynamoDB, which is a NoSQL database. And then you have something called as Aurora Serverless, where your database also scales automatically based on the number of requests that is coming in. And then there is another offering called as RDS, which is basically a managed a database instance in the cloud, where you have a MySQL server that is running, but just that you don't maintain the server, right? So this is on a high level what it would look like in the modern three-tier application, right? Next. Now, why would someone want to go to serverless? Right? So the various reasons are, first thing is there's no servers to provision or manage, right? The headache that we discussed in the very beginning, the patching, the load balancing, the costing, budgeting, everything is taken care. It's out of your hands. That's brilliant, right? All you worry about is writing your application logic, which is basically your algorithm, your foolproof and the algorithm that takes care of lossless algorithm that takes care of converting JPG to PNG. Your main focus is that, right? So that is no servers. Then configuration less scaling. As I have already mentioned, it can automatically scale without you writing a single change. So if today there is one request that is coming in, it will serve properly. Tomorrow there are 100 requests. You don't have to change anything. With serverless applications, it is going to serve automatically. Day after tomorrow, it's 10,000. Then there's 1 million requests. It is going to scale automatically without you taking any care. You don't have to configure for anything. It's just going to scale automatically. So that is another advantage of why we should go to why serverless. Built-in fault tolerance. So what happens is, because you don't maintain the server anymore, what happens is if there's something happening to the server that is serving your serverless application, AWS takes care of the responsibility to make sure that those servers are always up to date in terms of security patching, in terms of reliability, in terms of availability. Right? Availability meaning it'll AWS is going to promise or ensure that a particular server or infrastructure is going to be available for you when you run your serverless applications. So you will have built-in fault tolerance. That means AWS is taking care of it. You don't have to worry about it. And or if at all something happens to the server that was serving your request, if it goes down, AWS takes care of the responsibility of bringing up another infrastructure or another server for you to serve the requests. So that is built in fault tolerance. And as we already discussed, pay as you go, you pay only for how much you consume. In Ola or Uber, you pay only for how much I travel. Whereas in Zoom car, you pay for the number of hours, right? That's exactly what a virtual machine is. You use it or not, if it's sitting in your parking, it's not in Zoom car space, you have to pay for it, right? I don't care if you're using or not. You just have to pay because it's not with me and it's with you. It's as simple as that. Bring your own code. Essentially, it means that no need to develop from scratch. Just upload your own code and run. Again, we'll have to probably make some few changes or few tweaks to ensure that this is running as a serverless application. But then you don't have to do a lot of changes when you want to migrate from a normal application to a serverless application. There'll be a few changes, but not a lot. So that should not be a stopping point. Now, as I said, what exactly it is with working with serverless. So you have a list of event sources, and in the middle you have the serverless functions, which you pay by usage, and then you have another set of triggers that can trigger other services. So as we had already discussed, let's say for example, changes in a database or S3 bucket, right? When there's an upload to an S3 bucket, you can trigger a Lambda function. The Lambda function takes care of converting that JPG into PNG and upload it back to another S3 bucket, or update something in a database, or call another Lambda function to take it forward. Or as we discussed, we can trigger some SPS, some queues or event bridge, where that event bridge will take care of sending emails to the particular whoever was requesting it, right? So this is how it works in the serverless world. Everything is event driven. What exactly does event driven mean? In the serverless world, as I said, what happens is there's no pre-available infrastructure for you. As we discussed in the very beginning, I am provisioning a 2 GB RAM machine. That's not the case here. I'm not provisioning anything. All I'm doing is I'm writing my code and uploading it to the cloud. That's all. I'm not going to say provision a 2 GB RAM machine that is always running. I'm not saying that. I'm just writing my code and uploading it. And I also configure saying that if at all a request comes in, what should my machine that is being provided for me, a server for me, what is the power that is going to have? It can be, again, that is something that is configurable based on your application. You can say, okay, when a request comes in, when AWS is provisioning that infrastructure or server for you, it is going to have this much of memory, this much of RAM, this much of CPU power, also a few of those configurable things you can provide with Lambda functions. So that is all we do. Now, we took this example of uploading or converting images, right? Now, what will happen if there are no requests coming in? You will not be charged anything. You don't have to pay a single rupee to AWS because your code is not running and your application is not serving any request. In a true serverless application, what happens is you only pay to the cloud provider for the amount of time your code is running. So if there is one request today, you pay only for one request. If there are 100 requests coming tomorrow, you pay for 100 requests only, right? So let me give you a simple analogy again why serverless from a costing perspective is very advantageous when you're building applications, right? Let's take the scenario of Book My Show, right? Where we use Book My Show to purchase tickets, right? Now, because of this COVID situation, all theaters are shut down, right? Essentially, which means that Book My Show is almost out of business. They're not selling a single ticket. Therefore, they are completely running in losses, right? Because they're not selling any tickets. Now, just because they know that there are no theaters running and there will be no one who can purchase tickets, and every user, right, all of us also know that we are not going to purchase tickets. Just because both the provider and the consumer are aware that this service is of no use or redundant anymore, does that mean Book My Show will kill all its web servers or bring down its website? No, right? Even today, if you go to Book My Show, you can see some data, some content on the website. So obviously, there is a web server that is serving those requests, right? Now, imagine a similar scenario for your application, right? Where in some situations there is no request coming in at all. You don't have to Just because I anticipate some crazy person to come to book my show, I have to run my website, right? I cannot shut it down, although I know there's no use of people using book my show in this situation, right? Just an example, right? Now, just because of that, I cannot kill it because I don't know, someone might come for whatever reason it is. So what happens is if you have a normal web server running in an EC2 machine, you will pay 24 bar 7 because your website should be always up and running, right? You pay 24 bar 7 even though you know and the consumers know nobody is going to come to you. In the serverless world, it's exactly opposite, where you pay only for how much you're going to consume. That means you pay for the number of requests coming in and serving. So in the bookmaker example, if it was built with serverless, what would happen is it will not be charged anything at all as long as nobody comes. But if at all someone comes, automatically infrastructure magically is provided. A server is magically provided for your application. Your application runs and serves the request, and you are charged only for that request. Isn't that beautiful? Isn't that powerful? Right? Because you can simply just get your applications up and running without a lot of configuration. So that is with the working with serverless. And these are the various use cases with serverless. You can do data processing, that is real time or batch processing, and then you can do web applications like static websites, complex web applications, single page web apps, and sort of things. Then you can have a chatbot. Again, chatbots are one of the best use cases because a chatbot is something that comes into life when someone is chatting with it, right? So it's exactly a perfect fit for a serverless world. It's similar to what an Alexa is also, right? Alexa skills, where someone is asking for an Alexa skill. That is when you come into picture, the Alexa skill comes into life, serves that request, and goes back, right? So things like that are perfect use cases for serverless applications. Then you have backend as a service where you can build your entire application. Config, which I talked about, is a ticketing platform, just like Bookmyshow sort of, which is completely built on serverless technologies, right? So you can have your apps, you can build APIs, you can have mobile backends, IoT, Internet of Things, right? So you have a lot of sensors that is sending a lot of data for you. Then you have a Lambda function that gathers all that information, stores in a database, performs some kind of analytics, and all sorts of things. Then autonomous IT extending other cloud services, which is basically, I told you, you can add an email service, you can upload files to S3 bucket, all sorts of other things that can come into picture, and you can have n number of use cases that you can build with serverless applications and leverage the various advantages like costing, scaling, performance, and all those things. So these are the various use cases of moving to serverless or building serverless applications. Now, we have discussed all these points with just putting it out there. So they're so accessible for all developers, which basically means that there are a lot of languages with which you can write Lambda functions. Sorry, Lambda functions, and even if it's not natively supported by Lambda, you can bring your own language, uh, and you can have your code running. And obviously, Lambda functions are all these compliant ISO, PSI, and GDPR compliant. All sorts of compliances are taken care by the cloud provider. Lambda function is compliant to all these things. Greater productivity. What happens is toolkits for provided integrated development environments. That is from your VS Code or IntelliJ or PyCharm or WebStorm or whatever it is, you can directly deploy your services to the cloud. That is AWS Services, simplified deployment with nested apps, and then enable new application patterns. So with the Lambda functions, one thing I forgot to mention, it is, I told you, right, this infrastructure comes into picture only when you want to serve a request, right? So with Lambda function, one of the things that you'll have to keep in mind is your code can only run to a maximum of 15 minutes. It cannot run for more than 15 minutes. So that is one of the things that you have to consider. But then 15 minutes is too much to solve any request, right? So that's one thing. You have Amazon SQS. That's nothing but a simple queuing system where you can have multiple queues, which a Lambda function can trigger. Automatic load balancing for Lambda functions. As I said, you don't have to worry about the load balancing. AWS takes care of that. Support for Kinesis data streams, enhanced fan out and HTTP2. Again, I'm not going to touch on these technical terminologies because I don't know how many of you are aware of these services, so I'm just going to skip that point. There are trillions of executions every month for hundreds of thousands of active customers. So this is not like serverless is something that is new. There are so many products and companies that are leveraging and migrating to serverless because of the various reasons that I've already mentioned: costing, performance, scaling that is coming out of the box for you without doing any configurational things. Now, this is how it has changed over a period of time with, while migrating to serverless, where the architectural patterns are modular services. Earlier, you would have something called as monolith. Again, I don't know if how many of you guys know what is a monolith application. That means you have a big fat application that has so many features, everything relying or sitting in one particular place. That is what is called as a monolith application. Instead, in the Lambda world or serverless applications world, what happens is you are granularizing it. You're breaking them down into individual Lambda functions, and then it becomes more modular, granular for you to maintain, build, and enhance on top of it. Operational model, it is as managed as possible because you're not managing anything. All you're worried or all you're concerned is your code, right? Your lossless conversion of JPG to PNG images. You are not taking care of anything else. Now, the software delivery automated and standardized. So what happens is you have a set of CI/CD tools, and the deployment is straightforward and simple, so that you can move to production as soon as and as quick as possible. Management and governance, it's everybody's responsibility. It's what happens is a lot of responsibility is taken care by AWS. From an infrastructure point of view, but still from an application point of view, is the only thing that you will be taking care of. Data management is nothing is purpose built. As I talked about, what happens is in the serverless world, you can change your databases based on your feature requirement. Let's say one feature requires you to have a NoSQL database, you can have that. Another feature requires you to have a traditional MySQL database running, you can have that. You can have a serverless implementation of the same using Aurora serverless, you can have that as well. So because what is happening is when you move to serverless world, your big fat application is broken down to smaller chunks or smaller pieces called as Lambda functions. And each individual Lambda function can integrate and talk to its own database. This is what is called the microservices style or microservices architecture. And in the serverless world, we drill down further or granularize it further and call it something called as nano services. Okay, so now these are the various AWS services that is serverless. On the from the left hand side to the right hand side is basically the responsibility model. On the left hand side is something that you as an individual developer have to take care when you are consuming the services on the cloud. When it is coming to compute, that is a virtual machine. As we discussed, there's something called as EC2 machine, where AWS takes care of a little bit of it, where provisioning the servers, the power management, the electricity management that we talked about, cooling systems, all sorts of things is taken care by AWS itself. You don't have to worry about it. And then there's something called as MySQL. So you can run your own database inside our MySQL is an open source engine, right? So you can have your own server and you can run MySQL engine in that server. So that is also possible. Again, that is still running in the cloud. Then for analytics, you have Hadoop clusters that is running in EC2 machines. And then slowly, if you move further towards the right of the screen, you will have the complete service. Again, I'm not going to touch or talk about every single service that is available here, but towards the right, you have the complete serverless, where what happens is AWS takes care of the operational responsibility. You don't have to worry about the infrastructure that is running behind the Lambda function. DynamoDB S3. DynamoDB is the NoSQL database from AWS. S3 is again a storage service which we have already talked about. EventBridge, again something that we have talked about, which is an event bus that helps us connect with various other services. SQS is again a queuing service. SNS is a notification service that helps you send SMSs, sends you emails, and sorts of things. So these are the other services from a serverless perspective, from a messaging thing. right? So then we have the analytics. On the serverless mode, we have something called as Amazon Athena, which helps you run analytics on a lot of data. And then again, the infrastructure or the operational responsibility relies with AWS and not us as individual developers. So this is about the various AWS operation responsibility models from left hand side to the various services. Again, AWS offers all the services that you take care, you maintain everything, versus it taking care of a lot of things and taking things away from your hand. So that is about kickstarting or getting you understand about the various services in AWS and give you a brief understanding of what serverless applications are and how you can build them and what are the various services. Especially for students, I would recommend you guys to start with serverless because you can build some small applications very easy, very quick. And for students, like all of you, one of the important things is costing, right? You don't want to have a server. You want to build an application, but you don't want to break your pockets or burn a hole in your pockets to serve that application, even though there are not so many people who are consuming it. But just because you built an application, it has to be there, right? Let's say you are applying for an internship or you are applying for a project, you will obviously mention this link, right? It's not like you at that point in time you bring up that application into picture and then that is served. So you don't have to worry about all those things. Quickly build some small applications, some small POCs or your pet projects that you guys want to do and deploy it with serverless, and everything is taken care. You don't have to worry about the infrastructure, and all you have to worry as a student, all you have to worry about is code, right? You don't want to take care of what is an EC2 machine, how much RAM should I provide, how do I do load balancing, and when I want to have an API, how do I do that? All sorts of things are much 100 times easier in a serverless world. So that is about it on how you can kickstart your journey with AWS and serverless in particular, and build some crazy applications in very small amount of time with very less effort and not paying a lot of money. So that's about it for the session. Do I have any questions?
Yeah, I'm pretty much sure that everyone have a question regarding this session. So let's wait for questions. So the first question is, what about
Uh,
backups?
oh, okay. I don't know. I mean, that's a very generic question of what about backups. So I'm assuming a backup of data, because that's the most important thing from an application perspective, right? Where you want to back up your data. So when you move to the cloud, again, this is the advantage, right? So automatic backups come into picture. So if you had a server that you are doing, you have to manually take those backups, right? To ensure that you're storing that backup somewhere, to ensure that something happens to the main database server, you have a backup available for you. In the cloud, let's say an RDS, which is a managed MySQL instance that stores all of your data, you have something called as automatic snapshots. What it does is every day in a given point in time, AWS will automatically take a snapshot and store that snapshot so that if at all the main database goes down, you can still bring up another database with the data from here. So snapshot is pretty straightforward in the cloud, wherein you can take snapshots and restore those restore databases using those snapshots. Again, it is very straightforward.
Yeah,
Uh,
okay. So the next question is from Habib. So he want to ask, why do I need to learn cloud? What are the use cases or what is the use?
okay. Uh, okay, so why do I need to learn cloud? Well, probably you should not ask that question now, given that every single application is in the cloud, right? Including finance applications, right? From an application point of view, on-premise is something that is a lot of burden as a developer or as a company to maintain, right? So from an application perspective, moving into the cloud takes away a lot of pain from your hand, and everything is taken care at by the cloud provider. You don't have to worry too much about let's say for example, I gave you this example, right? You have too many requests that is coming in, and let's say your application is running on-prem. That means it's running on your own server, which is in your office. There are too many servers coming, requests coming in. How do you scale? How do you make sure that all the new requests are coming in is scaled, right? So you cannot go and get a server just like that, right? And attach it to your fleet of servers that is already existing, right? So from an application perspective, it is simpler to scale and serve more requests, manage, maintain everything if it is in the cloud. Whereas if it is on-prem, it's a little difficult. Now coming to what are the use cases, I think that was the question, right? I've already mentioned what are the users. Okay, as I've already mentioned, you can build applications just like that on the fly, and you have so many requests coming in. I showed you the use cases, right? You can build chatbots, you can have automated IT batch processing. Let's say you want to run something every day in the night. Let's say you want to do some web scraping, right? You want to have some data that is scraped from a website every day, some stuff like that. All of this can be easily done with serverless and in the cloud. So I'm assuming I've answered your question.
Yeah, yeah, you. So the next question is K. Dushyant Reddy. So he's asking why serverless are said as a serverless, even though if they are on so many servers serving the request.
Yes, I think I already answered this question while I was talking, right? See, serverless is for us as end users or developers, wherein you don't have to manage or maintain that server. That's all. It's not that, there are no servers. Obviously, you want to run something, it has to run on a machine, it has to run on a laptop or a server, right? So behind the scenes, obviously, even though it's called a serverless, there are servers that is where the application is running. It is just that you as a developer are not concerned or worried about maintaining those servers. That's the simple reason. There's no other reason why. Okay.
Yeah, the last question is which one is better, firewall or SC3? S3.
Okay. So what exactly is the difference between Firebase? See, Firebase is again an offering I mean, it was acquired by Google, right? So Firebase in itself was a cloud sometime back. And S3 is a service inside AWS. So it's not a proper comparison to do Firebase with S3. Again, in Firebase, you have something called as a storage, right? Where you can store your images or objects or files or blobs or whatever it is. So if we do a comparison for Firebase storage versus S3, there's not much of a difference. It's like two different cars from different manufacturers, right? It's from a different cloud. Firebase is now handled by Google Cloud, whereas S3 is from AWS. But one thing I'll tell you about S3 that is brilliant. Actually, S3 as a service is claimed to be the best service in the entire cloud. Not just AWS, it is actually turned as to be the best service across clouds. Now, again, for people, I don't know how many of you know, there's something called as reliability or availability. Okay, so what it means is that as a service that is provided, how often does it go down? Because it's also a service, right? It's also a server that is running the service. It can also go down. With S3, there's something called as 11 nines. 11 nines means AWS guarantees that S3 as a service is going to work 99.999. There are 11 nines after the decimal point, right? So that much of guarantee AWS provides, and that is why S3 is the best service in the entire cloud, actually. Firebase is a brilliant cloud, if I can call it, where you have authentication and you can build mobile apps, and it's easy to get started with. Again, with Firebase, I agree. But when it comes to reliability and availability, there's no service in the cloud that can beat S3. Yes. I
Yeah,
hope
so
I've
I
answered
can.
the question.
Yeah, I can
Yes.
also see like all the questions are getting answered. So So thank you so much, Srushith Tripakula, so giving this wonderful session, and I'm pretty sure that everyone get clear with the concept of serverless. So still anyone having an issue regarding this webinar and this session, so you can connect with Srushith on the Twitter as well as on LinkedIn. So you will get you can see this LinkedIn link on the screen, and this link is also available in the description. So you can also go there and you can connect with Srushith from there. So thank you so much again, and thank you so much, Rashish, to you also.
Thank you so much for everybody who has joined. Thank you.